Hi everybody, this is Professor Terracciano, and I'm here in the Classic Synthesizer Laboratory at University of California, Irvine, in order to talk a little bit about electronics and their impact on music. So let me speak for a little while, and then I'm going to demonstrate some of this lovely equipment that I get to play with on a regular basis. So, first of all, how does electronics relate to music? Electronics has a very important role in our understanding of music and had a tremendous impact on our ideas about the types and styles of genres. Also the level of volume, the way in which music could be recorded, and the way in which music can be constructed. And it also opens up a new universe of sound. So how does all this happen? First of all, I've talked briefly about what sound is, and so I want to remind you that sound works in physics anyways as follows. Air pressure against your eardrum is constantly changing. That modulating air pressure will generate in your brain signals that we translate as sound. The typical sound range that our ear can hear is from about 10 changes of pressure per second to about 3,000 changes of pressure per second. And those different frequencies, those changes in pressure at a certain speed, are what we decided to call pitch. So a pitch is a very specific oscillation in air pressure against your ear. All right, once it was figured out that those oscillations in air pressure could be translated into oscillations in voltage, everything starts to come into fruition. So there were two early breakthroughs in music and music technology. One was the generation of the very early type of synthesizer called a theremin. Mr. Theremin was a Russian inventor who later went back to the Soviet Union and created the first electronic bug. He was quite a brilliant inventor, and his story is incredible. If you ever get a chance to see the movie Theremin, I recommend it. He discovered that the simple electromagnetic fields around our skin could interfere with radio waves, and we never even had to touch the sensors in order to interfere with the radio wave. So he built a machine that you played by moving your hands in the air around radio receivers, and that signal would generate these tones, and it could be played by changing pitch by moving one hand and changing volume by moving another hand. And it became a very famous electronic instrument that dates back to the 1920s. So this would be the first synthesizer. So the other major invention is the microphone, and the microphone and the speaker that accompanies using the same technology works as follows. If you have a stationary magnet with wires going through it, and you have a magnet above it that is changing its distance from the stationary magnet, the voltage read across that wire will fluctuate based on that distance. So if you suspend that upper magnet in some sort of flexible material which will respond to air pressure, just like our eardrum would, that magnet will be constantly moving at the same rate as those changes in air pressure. So that electrical signal becomes another way of representing sound. And these two innovations are quite extraordinary and have a big impact on the musical world. The first pieces to use electronic sounds date back to the 1920s. You have several examples in your listening list, including a piece by Mr. Varese, who was probably the very first to use electronic sounds. Once we start thinking about electronic sounds, we start thinking about a whole new universe of sound, and we start to move away from pitch as the defining tool for constructing music. And that begins early in the century and really comes into full flower in the second half of the 20th century. The capacity to record and to generate electronic recordings of music allowed for greater and greater refinement in the process, including amplification as well as a much wider spectrum of sound. Even though that early analog recording in the Victor playing machine that I played for you in the previous video is quite strong and quite wonderful, the accuracy of sound starts to improve as we start to refine the voltage. Okay, now let's fast forward. So if sound can be recorded as a voltage, why can't voltage be sent back as sound? So the simplest possible sound, for example, would be something called a sine wave. And the sine wave would be a very regular oscillation of air pressure, where the oscillation would go down to a certain amount of pressure and release to a certain amount of pressure, and there would be some 0 point where there is no pressure change at the beginning and end. So you would have a shape that looks like an S that's laying on its side. And every time we make that downward and upward pass on the voltage, we are creating a certain frequency. And the frequency is how many times we make that downward upward pass of voltage over time. And that is a pitch. So let me play you a pitch. That's a very simple sine wave. All right. So there's a man named Robert Moog who passed away only recently, who was an incredibly innovative inventor and musician. He built his first theremin in the 1950s from a kit that he bought from Scientific American. And from then on, he was hooked with the idea of creating synthesizers. His most famous creation is the Moog synthesizer, which is actually a series of synthesizers. What is a synthesizer? All right, we have to remember the word synthetic is the root of that word. So synthetic essentially means artificial. So if you can record sound as changes in electronic voltage and record that information to a medium such as electromagnetic tape, why can't you create voltages and then listen to what those voltages sound like as sound, since you can play those voltages back through a loudspeaking system? So this machine is actually many little modular devices which are connected via patch cords. So in the early days of synthesis, what we had was a machine where you patched different sounds together and different filters, and you would generate interesting sounds. So essentially what we have here are three types of component. We have a mixer, which mixes all the sound together and sends an output, which we have going out to these two speakers. And we have oscillators. And oscillators, all they do is generate a voltage. And that voltage can be controlled through these dials. So we also add another layer to this. We add filters. Essentially, a filter affects a voltage. So if you play with the voltage, you can play with the sound. Let me give you a simple demonstration of that. Here we have this oscillator here playing this pitch. There's a device over here next to it which essentially says, put a voltage in here and I will affect this voltage with that voltage. In other words, you're mapping another set of information on to the first and forcing it to fluctuate. So we can take a second oscillator. We'll take the one right next to it. And we have four choices of waveform. We have the sine wave, the sawtooth wave, the pulse, and the triangular wave. And you can imagine how those could be read. Let's take another sine wave. We actually hear that second sound wave. That's because I've lowered the pitch to be such a low sound on the second oscillator that we actually can hear the period of it. If you wanted to hear that actual sound, this is what it would sound like. In other words, it is going so slowly that instead of hearing an actual tone, all we hear are electronic pulses. So that's the speed of that sound. And as we speed it up, we slowly get closer and closer to pitch. And now we're closer to pitch. Okay, so I took that sound and I use it to affect the first sound. We've already entered the land of science fiction from the 1950s by doing such a simple little filter as that. And that output can then be used as a filter for another oscillator if we want to do it that way. Let's add one more layer of filtering to see what interesting things we can get. And you can start to hear the different waveforms. Start to hear the different waveforms compete with each other and to shape each other's format. All right, so the wonderful thing about this machine is this realm of sound, which is so extraordinary that it opens up. The problem with this machine is, how do you play it? Do you perform it in a concert with a conductor and then you move the dials as fast as you can? Yeah, you can do that. How will your accuracy be? Not very good. And so I think that the problem with the Moog synthesizer is its interface. Just dials and patch cords, and you want to change the sound, you got to pop a patch cord in, you have to hope that the cord is working. So it was wonderful for generating recordings, and then you could play with those recordings. It was not so useful in live performance situations. And so people started to adapt different kinds of controller, like the ribbon controller and the keyboard controller, so you could actually send discrete measured voltage that are read from keyboards and from that strip controller. So all of this stuff is quite wonderful. Okay, so let's summarize a few points about electricity. What are the things that it impacts? First of all, it creates a universe of new kinds of sounds. By simple control of voltage, you can generate a wide range of sounds you might never have imagined before. And that's really been the challenge of the 20th century into the 21st. What kind of new sounds are wonderful and useful? They get dated really quickly. Second of all, amplification. The amplification of sound has changed the way in which we distribute it and the way in which the social arena for music has changed. Filling up a giant auditorium that's meant for a sporting event is no problem anymore once we have amplification of the sound. Third, we have the mixing in the studio of music. In other words, we start to create music that cannot be heard live. And that is something that is only true in the 20th century. And this is true in the classical world, where recordings are mixed and spliced together, but it's also true in the rock world. And the producer starts to take on a greater and greater role in the final product of a rock band or an artist who's creating music. A lot of things that you hear and that you purchase now are not doable live because they need several different sets and layers of sound to be going on at the same time, and they would be unwieldy to do live. It is quite often the case that when a singer is performing, they're usually playing with a soundtrack that they're singing over in order to recreate the experience that you get from a recording. So that is a major change in our experience and our expectations about music. So those are the big 3 points I wanted to point out, and I think that as we get nearer and nearer our final goal of understanding a way in which we can categorize and understand the music in our lives, we can see that electronics plays a big role in that. Talk to you soon.